So now E2 elimination. All of you put that in. What? In the half an hour you are thinking. Still half an hour we have to bear him or what? Only half an hour in. E2 elimination. E2 elimination. Okay, what are the points? It is a single step, bimolecular. Rate of reaction depends upon both alkyl halide and base. So it follows second order kinetics. So first is bimolecular, one step process. So it is one step process. One step, bimolecular. Next one. So I will give the mechanism first, then we can talk. So CH, very important point is there that I will tell you. Next. So this is your saturated compound because all 4 bonds are out or not, you check. For each carbon 4 bonds are there, saturated. Abhi base, it will come from back side like this, and this bond will come like this will go like this. So there is a transition state. In that transition state, the bond, listen, I will give time. So in that transition state, boron and hydrogen will get a bond, dotted bond, because it is a new forming, and this is eliminating, and again there is one more new forming. See how I am writing the dotted structure. This is a forming bond, this is a leaving bond, eliminated bond, and again a new bond is formed here, understanding, and again a bond is eliminating here. This is called as a transition state. So remaining Jobita over here. This is transition state. After some time what happens? After transition state, this is TS. So this bond will form and BH will go minus BH because this bond is forming. So here and here there is a double bond. Here and here there is a double bond. And what else is left, children? X minus also left. So here very important point is the both eliminating groups are trans-periplanar to each other, anti-elimination. So here H is like this H will be otherwise. Periplanar relationship should be there. Anti-hydrogen only will remove. So this very important application is there. I will tell you that point you write first. What is that point? The orientation of the proton and the leaving group should be anti-periplanar. The orientation of the proton and leaving group, LG, not TV, and the leaving group should be what? In anti-periplanar relationship. Should be anti-periplanar. This is the extra point which you are learning in E2, but not in SN2. So there also transition state is formed. So the rate is no doubt, rate is directly proportional to alkyl halide and also the base concentration, children. That is why it is a second order kinetics. So that is the main thing. And the order I told you, what is the order? 3 to 1. Fine. So now we will have one more elimination, that is Hoffman elimination. I will teach and then we will leave. Hoffman elimination, 4 conditions you will get. What is Hoffman elimination and what are the conditions we will see, and then we will find out. Before going to that question, this based on this line I will give one topic. This line you understood? I will give one question so that you will be understanding it better. Suppose they have given like this, one Br with a rigid bond, okay, and here some CH3 is there in a dotted line, okay, CH3 is there in a dotted line. So So obviously hydrogen will be like thick line only, no? Hydrogen will be with the thick line. Like this one product is there. And they asked which product is formed on elimination. If I gave base here, eliminated product. So what is the correct answer here? So we may think that this will come. Why? Because Br is here, here H will remove. So I will get a double bond here. Understand? And how many bonds are there? That only no. Br I am eliminating and H I am eliminating. So CH3 will be like that. How many substitutions are there? How many substitutions are there? 3 substitutions. Very good. And one more possibility. This is also beta. This is also beta. No. This is beta and this is beta. No. One more possibility is what? One more possibility is what? Yes. Yes. But what will come? What is the right answer? What is the right? Can this product can form? Means what you are thinking, like this if they gave, we can have 2 chances. And according to you, what is the right answer? A is the right answer. Right? Because more substitutions are there. 3 substitutions here, 3 substitutions. And here only 2 substitutions are there. 2 substitutions because 2 hydrogens will be there. You are thinking that this will be product. But answer is this. Why? Answer is that, not this. This is the thing. The orientation of hydrogen and the leaving group should be anti-periplanar. Means one is in wedged bond, the hydrogen should be in dotted bond. Hydrogen should be in dotted bond. Then only this hydrogen and Br will be eliminated. But here you will have 2 hydrogens, no? Here you will have 2 hydrogens, one with a wedged bond and one with a dotted bond. Yes, I will remove the dotted hydrogen. Why I will remove the dotted hydrogen? Because these 2 are in anti-periplanar relationship. Elimination is possible, which is the necessary condition. Are you understanding? Any doubt here? So why this hydrogen can't be eliminated? Because both are in the same direction. That is not a periplanar relationship. Understand? So anti-periplanar relationship means one leaving group is in thick line, then the other should be dotted line. Or this is in dotted line, other should be in thick line. If they mention, if they won't mention, yes, no doubt, this is your product. If they are not mentioning anything, means simply I gave like this, then that is your product. Because I can take this hydrogen as dotted line, no? I can take, no? If he is not giving, I can take this hydrogen dotted line and this CH3 thick line. Dotted line means these 2 are away from each other, anti-periplanar. I can remove. Are you understanding this point? Right. So this product won't come. This does not come and this will. Even though less substitution is there. So this is the exception point. Okay children, now U2 elimination is over. Put the heading Hoffman elimination, and there are 4 cases that I will teach and then I will leave you. Hoffman elimination. So same definition. In an elimination reaction, less substituted product is formed as a major one. There I told you, no. In an elimination reaction, if there is a chance of more than 2 alkenes, then what happens? Less substituted one is formed as a major product. Less substituted alkene is formed as a major one. Is formed as major one. When there is a chance of more than 2 alkenes in an elimination reaction, then the least substituted one is formed as a major one. Least substituted. That will take place in 4 cases. What is the first case? If the base is bulky, very big base you have taken. If the base is bulky, means what? I have taken very simple example, I will tell you, not a big one. Simple example. This is your 2-bromo-butane. Everyone knows what are the products? Generally base you छोड़ दो, base को छोड़ दो. What are the products? 1 butene and 2 butene. If I remove H here, 1 butene. If I remove H here, 2 butene. Any doubt in this? No doubt? Okay. But if the base is like this, tertiary butoxide means butyl alcohol you take and then you add O minus. Tertiary butoxide. This is a bulky base, big base. That time you will get 1 butene as the major one, children, and 2 butene is the minor one. Even though more substitutions, more stable, anything, this will be 80%, this will be 20%. This is minor, this is major. Okay? If I add methyl alcohol, normal base, methyl alcohol, normal base, and heat, then I will get reverse. Then I will get 1 butene as the major one, 1 butene as the major one, 1 butene as the minor one, and 2 butene as the major one. Reverse. This is called Sage-Jaffe rule, and this is called Hoffman product. Okay? When bulky base is there, Hoffman is the major one. When small base is there, weak base or small base, then Sage-Jaffe is the major one. Are you understanding? First point. If the base is bulky, this is the major one. Second case. Second case. What is the second case? If there is a poor leaving group, if the Lg is poor, if there is a poor leaving group like fluorine or Nr3 plus or Cl minus, like that, that is a poor leaving group, that time also you will get an Hoffman product. Whenever there is a poor leaving group, I will tell you, when the leaving group is poor, like CH3, CH3, F, CH2, CH3. Yeah, what is doubt? What is your doubt, right? This is a poor leaving group. Then you take normal base only you take, and heat normal base only, simple base. That is not a bulky base. What is your doubt? Ask. No problem, ask. Niranjan, today you won't come, I think. What is your doubt, Nana? Tell. No doubt. Normal. So this time also, which is major one, children? Least substitution is the major one. So here I am writing alpha hydrogens with red pen. Luckily today we are having red pen. So these are the beta hydrogens. So what can be the product? CH2 double bond CCH3, single bond CH2 CH3. This can be one product plus. And what is the other product? CH3 double bond C. Just I am removing H, that's all. So generally, which is more stable, you tell? Second bench. Second one is more stable, first one is more stable. Second one. Why? Correct one. 3 substitutions. And first one, 2 substitutions. But that is only major. Because leaving group is 4 and this elimination is Hoffman elimination. Third point. Third one. If the beta carbon is heavily substituted, if beta carbon is highly substituted, you can write steric hindrance, sterically hindered means very big group is there at the beta position. then also elimination takes place. Means this one is there. Every time I am writing now write the normal Br only or else CH. Okay. This is alpha carbon, beta carbon. Beta carbon is heavily substituted. Very big group is there. Beta carbon. Okay. Heavily substituted. I can write here C2H5 anything. Now also I will get half-man product is only major one. Means CH3 no shifting and all. Just you can have this one as major. That's it. That is the least substituted one. Only one substitution, but that is only major. This is only major. You may get many products here. Okay, you will write other products also, children. So what are the other chances here? Here you will get a carbocation, and this will move like this. And after that a tertiary carbocation is formed. So you will get one more product, that is this one. But this is minor only. After shifting only I am writing. This is minor. After shifting only I wrote. So first पहले एक कार्बोकैटायन आया, उसके बाद इसको शिफ्ट किया. This is 2-butene, but that is minor, children. Minor. So 3 cases over. Last case. Are you understanding? First case, bulky base. Second case, poor leaving group. Third case, beta carbon is highly substituted. And fourth case, if beta carbon contains double bond or triple bond. If beta carbon contains unsaturation, means either double bond or triple bond. Means like what? CH2 double bond CH, just I am writing. And this is only my beta carbon. Now alpha carbon is this. This is beta carbon. Okay, like this suppose is there. Beta carbon is having a double bond. So beta carbon contains this double bond. Alpha beta. Beta carbon containing a double bond. Here unsaturation should come down. Okay. Okay. So now, what is the chance here where you can get the hydrogen? Suppose here if double bond is broken, you will get an unsaturated compound CH3 double bond CH2. So the more subject, you will write all the two products and then we will decide. You will write all the two products. CH double bond CH. This is one product. Means I have removed the hydrogen from which place? I have removed the hydrogen in the left beta. Now right one is there. That also I am writing. CH2 double bond CH and again CH2 single bond CH double bond CH2. Okay. So this is major one. Because one substituted, there two substitutions is there. So that's all. These are the 4 conditions where we can find the Hoffman elimination product. So one is base is bulky, second one poor leaving group, third one beta carbon is highly substituted or beta carbon contains a double bond. In all these 4 cases, what will happen? Hoffman elimination is formed, and all the remaining cases Church-Jeff elimination is the product. Okay. So shall you do one or two questions based on the Hoffman and Church-Jeff? So one question I will tell you. This is the example where the Church-Jeff elimination favors. One time they asked in the IIT also. That product is there. OH heat. Whenever heat is there, elimination, remember. Now which product is formed? So answer is propene, ethene, ethyl alcohol, like that many cases they gave. So this is the example comes under for leaving group. So for leaving group means we'll get the least alkene as a major one. So this bond will migrate, children. So this all will go and here H will go. So what is the product? CH2 double bond CH2 is the product. We cannot expect at all that one, but that is only the answer. Least alkene is only formed. Why? If I migrate like this, you will get what, children? Other possibilities also you will think of. If this is migrated like this way, then what is the product form? Can anyone? One propene, no? So among them, which is more substituted? Understanding? This is A pathway and this is B pathway. Like this, suppose is shifted. This is the B product, this is the A product. B shifted with A like this. Then here you will get a carbocation, ethyl carbocation. Next H you remove, alkene will form. If I shift like this, then propyl carbocation is the plus one and you remove H from there. So which is more substituted, A or B? B is more substituted. But that will be major or A will be major? Why? Hoffman. Understand? Understood why that is major? Girls? Fine? Because that is least substituted only will form major. That is called Hoffman elimination. So, Gargi, stand up and explain today's class full and then Sigma.